Hello, this is Josiah with 1111 Electric, and I'm coming this morning with you to talk about 5G. And we're going to go through some stuff right now and try and break it down for you guys. Share my screen here. And this is from Building Biology Institute PDF that they've put together on 5G, and I just wanted to go through it with you guys. Understanding the technology and protection strategies fact sheet. 5G describes fifth generation cellular technology being introduced into the coming decade of the 2020s. It's not 5.8 gigahertz, a Wi-Fi and cordless telephone frequency used for years. 5G primarily involves data connections, not voice calls or text. Voice and text use 2G, which will be phased out, and 3G, but voice and text will be managed by the data network. 5G will continue to include 3G, 4G, LTE technology transmitting in the sub 6 gigahertz. So 600 megahertz to 6 gigahertz range for decades to come. Over time, new 5G antennas broadcasting in the super 20 gigahertz millimeter wave or mmWave or mmW band 20 to 100 gigahertz would be deployed. These super 20 gigahertz 5G antennas are proposed to be mounted at existing 4G macro cell tower sites, as well as in many small antenna arrays closer to homes and in public places. 3G and 4G LTE antennas transmit in the sub 6 gigahertz band would gradually be replaced by new antennas containing updated 5G technology. That new technology would include many elements under development for decades. Massive MIMO to increase the number of cell phone users in a given bandwidth and geographic area. On-demand beamforming, at least down to 2 gigahertz to reduce interference between and an increased number of cells signals in the same airspace, and to allow 5G signals to penetrate buildings, full duplex to save bandwidth, dual capable 4G, 5G cell phones, increased automation of the network, and placing both 4G LTE and 5G antennas on small cell antennas closer to users' handsets, near homes, businesses, and public places. Specifically, 5G proposes to bring 3G, 4G, LTE, Wi-Fi, and new 5G antennas closer to people through millions of small cell antenna arrays. 5G would be first be deployed in pockets of dense population in urban centers located in public places on and within buildings and at existing 4G cell sites. Public Wi-Fi antennas would also be mounted on overhead utility poles on cable company lines. The health effects of chronic exposure to cellular voice and data transmissions at a frequency in any generation are known to be harmful to all life, cumulatively over time and at close range. That includes the cell phone in your pocket. Exposure to 5G signals at sub 6 gigahertz and super 20 gigahertz bands are expected to accelerate the onset of ill health in people, pets, native animals, insects, plants in the biosphere, which are already under assault by RF transmitted by 3G and 4G LTE technology. 3G and 4G LTE antennas and technology would remain in place and continue to expand during the decade of 5G. Those who have developed microwave sickness, also known as electromagnetic sensitivity, are particularly vulnerable. Urban environments will be quite unhealthy for them, for the rest of us, particularly when we are outside buildings. The needs of these individuals must be taken into consideration by public policymakers as they are harbingers for the rest of us. Signals from 5G antennas transmitting above 20 gigahertz can only penetrate into our homes if beamforming technology is used. Otherwise, the millimeter wave signal does not pass through the standard building materials nor glass. Beamformed 5G signals at a frequency can be effectively stopped with RF shielding paint and building grade metal foil. Unfortunately, most fabrics, as well as copper and aluminum mesh that effectively block RF signals below 6 gigahertz are not expected to be effectively blocked 5G beamform signals above 20 gigahertz. Special silver fabric, however, may be designed that will be effective at blocking super 20 gigahertz signals. New 5G antennas will only transmit a beamform signal when a user's handset initiates a connection on demand. Beamform signals would not scan the neighborhood and constantly transmit like existing 3G, 4G, and LTE non-beamforming antennas do now. However, always on 4G LTE antennas would be installed along with 5G antennas at wireless telecommunication facilities or base stations, which are additionally names for small cell antennas right in front of people's homes. Activists believe the vast expansion of always on 4G LTE and Wi-Fi antennas close to homes in residential neighborhoods will be as much of a health risk as on-demand 5G beamform signals. RF meters in use today can only measure 4G, LTE, Wi-Fi, and 5G radio frequencies up to 2.7 and 8 and 12 gigahertz. Depending on the model of your meter, RF meters in use today cannot measure 5G signals in the super 20 gigahertz range. Spectrum analyzers and RF meters do exist that measure super 20 gigahertz signals, but they are expensive. Also, since they are measured in average mode and only use diodes for signal detection, they are not sensitive or effective enough, according to some RF experts, to measure the type of signals proposed for use in 5G above 20 gigahertz. Fortunately, new affordable RF meters are under development that will be designed to measure specific 5G frequencies planned for use by the cell industry in the super 20 gigahertz mmW band. 5G is not a done deal. Deployment would take longer and be more involved than most people, including industry, believe. Deployment is being challenged worldwide by an ever-increasing number of activists and advocates who are making progress at getting municipalities to delay or block implementation. Health effects of the 5G technology need to be fully and impartially studied before deployment of more 4G LTE antennas or any new 5G technology occurs, especially close to where people live and in public places. Field testing by the cellular industry shows that beamform signals can reach up to at least 1/2 mile with downloaded speeds of 1 GPS. Municipalities should therefore mandate that new cell antennas of any generation, whether 3G, 4G, LTE, or 5G, as well as public Wi-Fi, be placed only in commercial and industrial areas and not in residential neighborhoods. There should be a 2,500-foot setback between wireless transmission facilities, small antenna arrays, and residences. 5G transmitters, if they are deployed at all, should only be located with existing 4G transmission facilities and mounted at least 150 feet up, always above the highest roof line of neighboring houses and not at ground level. It should be remembered that 5G signals need a clear and obstructed straight path to reach their destination, which is the handset of the subscribers. Hill trees and buildings all block RF signals to varying degrees, and particularly in the mmW band above 20 gigahertz. Also, super 20 gigahertz 5G signals will not broadcast out in all directions continuously like 3G and 4G LTE signals do now. Remember, beamform 5G signals project in a rather narrow beam targeted at the user's handset on demand. The signal is powerful and very brief, emitting a burst of energy as it flashes past. Beamform 5G signals are designed to follow you as you move around with a cell phone or tablet in your hand. However, testing shows 5G signal is often lost when you move the handset. When that happens, you are handed off to a 4G LTE antenna. The 5G connection is stronger when the handset is stationary. You want to maximize the distance between you and your cell antenna by keeping a new 5G antennas in existing 4G towers. That dilutes the signal strength near people's homes. We also want 5G antennas up high to avoid beamformed signals from penetrating into upstairs bedrooms or to pass through one home to get to another one behind it. Effective hardwired alternatives to wireless connections do exist. These include fiber to the premises, as well as hardwired Ethernet cables within homes and businesses to allow occupants to cut back on the use of wireless devices. Hardwired data cables provide fast, stable, reliable, secure, and safe data and voicing connections. Once hardwired Ethernet connections are set up, then place your computer in airplane mode and make sure Wi-Fi and Bluetooth are not still enabled. In essence, avoid 5G devices and beware of 4G. Oppose sighting of 4G LTE and 5G antennas in residential neighborhoods close to homes. Support efforts to utilize hardwired fiber optic infrastructure that is already in place to provide high-speed data transmissions to our homes in a safer, wide way at a fraction of the cost of using wireless for the last mile. Join the efforts of 5G and wireless activists in alerting the public and elected officials to dangers of long-term exposure to wireless devices and all EMFs. Consider having your home evaluated by an EMF expert certified by Building Biology Institute. Follow the advice to reduce use and increase distance and favor hardwired alternatives to wireless connections and devices whenever and wherever possible. To learn more about details about 5G works and how to detect it and how to protect yourself and how you can get involved, purchase the full 57-page 5G online course at the Building Biology Institute's website. So yeah, I just wanted to go over that. It's a good little introduction to 5G and what's going on with that. So I'm just going to take myself off screen share.